So just as an introduction, remember to Euclidean that we have we're going to have grade 11 theorems integrated with grade 12 theorems. They can actually ask you explicitly only grade 11 theorems, and then give you diagrams that are assessing only grade 12 theorems. But essentially, we need to be familiar with CCT, right? Our three theorems related to a center, and then cyclic quad, and then tangent. Oh, tangent. Now, usually for tangents, remember there are three, but then there's that one that says tangents from the same point, they are going to be equal to the point of tangency there. You're familiar with that one, right? Right, and then we're gonna have tan chord. Oh, let's save this. We're gonna have tan chord there, and then we have the infamous tan perpendicular to radius. So if you have a radius then and this is a tangent, the angle in between them is going to be 90 degrees. Then apart, great. Right, then apart from these cyclic quads, remember that there are also three, and I think the one that pops up the most is opposite angles of a cyclic quad, that they are supplementary. And then let's also say exterior angle of a cyclic quad. Right, exterior angle of a cyclic quad, like this. And then angles in the same segment. Now this is also one that they like a lot, right, to integrate in these questions, so just be careful of angles in the same segment. And then for center, yes, like do they have to be like this? No, as long as 4 points on the circumference. And another thing is that it doesn't work if maybe let's say here are the points here and then it doesn't touch here. It doesn't work. But then those angles in the same segment would be equal. And then we have perpendicular line from center. Remember that it bisects the chord and its inverse. And then angle at center is twice the one as circumference. And then lastly, we're going to have angle in in a semicircle, in a half circle. So those are the 9 that we need to make sure that we remember. But then along with these, right, kindly revisit the properties of triangles, because they can be sneaky with triangles. I can give you a triangle right now that is like this, and we must know that if I can just call it A, B, C, we must know that here for angle C1, it's gonna be equal to which angles? To be equal to angle A. Exterior angle is equal to the interior opposite. You are definitely talking about a cyclic quad. C1 is gonna, yes, it's gonna be angle A plus angle B. Then you say exterior angle of a triangle. Yes. So now, what makes it different from this one is that here the exterior angle is equal to the sum of the two opposite interior. Are we together there? Perfect. So that's a theorem that they mostly likely to just like to put it there, right? So we just need to be aware of it. And then knowing also sum of angles in a triangle, and just remembering again that if I have a triangle like this, let's just call it also ABC, and then I know that this line is equal to that, which angles would be equal? C and A. Mhm. A and B. Aha. So these ones that are opposite the equal sides, the angles that are opposite the equal sides will be equal. So that means angle A would be equal to angle B. We say angles opposite equal sides. Are we still together there? Okay. And the same theorem, right? Or rather property of a triangle, what they also would like you to do is that if they ask you to say we got angle triangle KFC, and then they say to you prove that angle K is equals to angle C. If I were to ask you to prove that angle K is equals to angle C, what would, like, your approach is going to be aimed at proving what first? Exactly. So if we can prove that FK is equal to FC, then we could conclude to say therefore the angles are equal, meaning K will be equal to C, reason being that no, sorry, we can we could conclude that these are equal, but now our reason is going to be um yes. So if we prove that FK will be equal to FC, if we can prove that this, that, and that are equal, then it's gonna prove that angle K and C are also equal. Then we use angles opposite equal sides. You see, so you need to prove that those lines are equal there by using other methods, right? Okay, and that's what we have. And then along with these, then we have properties of lines. I actually learned this what do they call it, kind of like an acronym, ne? I found it in grade 10, quite a useful one. They say fun, they say what, fun talks, you know this, fun talks for the four triangles is simply confusing. Fun talks for these four triangles simply confusing. I didn't know that grade 9s are being given grade 12 work. This on its own, it summarizes majority of Euclid. In fact, it focuses more on grade 12 Euclid. When we say fun talks, we remember the corresponding angles, right? The co-interior angles, right? What about these ones? Alternating. Then there are these ones again. If I have an angle here and then I have an angle there, what would be these? Angles on a straight line. Angles on a straight line. Do you remember that they add up to 180? Yes, so that is the T part there. And then this one here, it's this one. That 0 there reminds us of angles around a point. Yes, angles around a point. Remember they add up to what? 360. Perfect. What about these that are looking at each other? Yes, vertically opposite angles. These are what we should make sure. Then for 4 triangles, it's just the 4 properties of triangles that we have exterior angle, we have all angles being equal to a 180 when you add them. Then we have angles opposite equal sides, and then we have sides opposite equal angles. You see, those are the 4 things or properties of triangles that we need to remember. Then simply, you might have guessed it, similarity. Our triangles are gonna be similar. Congruent, congruency. Right. Yes. So it's simply confusing. Mm. Mm-hmm. 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 So it's angles opposite sum of interior angles. Yes. Sides opposite equal angles, and then sum of interior angles. Those are the 4 things you need to remember. Then now for similarity, let's remember that here we prove that 2 pairs are equal. Prove 2 pairs are equal, and then the third one is just gonna be the third angle, right? And once you have proved similarity, don't forget to do the frog. The frog will remind us that the sides are in proportion, ne? The sides are in proportion. Then in terms of congruence, right, we have South African Airways, meaning that angle side. And then what do they call this one? They called it what? They're like, what? Sandwich, avocado sandwich. SAS. Sandwich, avocado sandwich. Yeah. Included angle. But usually I call this Vivian, if you can remember. Usually say should be 2 sides and an included angle. Then the famous right hand side, and we even forget that what is this RHS. We need to prove that we have a right angle there, right? We need to prove that we have a right angle, meaning that we need to prove that there is a 90 degrees in both triangles. Then another task is to prove that the hypotenuse of this side of this angle of this triangle is equal to the hypotenuse of the other, than any other side. You see, yes, that's part of congruency there. And then last one is simply side. So usually they like to put a snake here that is hissing. Yeah, you know how they teach kids, man. They make sure that they remember with common things, ne? But I found that it's actually very nice, because you will know that when I'm going to Euclid, I know my CCT, along with these other aspects of Euclid. Right, can we apply this on questions, gentlemen? Right, I found a document. Wait, let me just try to get it. Let's say Prince with okay, let's go to chat, say Prince, and then sequence and series Euclid. Yeah, here it is. I'm gonna send you this. In fact, let me send it now before I forget. This is a document I found that you can just use to revise most of the questions there. So let's send here and there. So please just confirm with me if you have found it. Now, if did you get it? Right, if you check there, section A is the theorems we need to prove. Remember those theorems from grade 11 and then the two theorems from grade 12. That's like from page 1 until page 4. Ne? Right, then after that, section B, it tells you that these are mostly level 1 and 2 questions. You see, level 1 and 2. So it gives you a nice section so that you know I'm here, I'm working on level 1. Let me just answer these ones and then I can move to the next ones which are more difficult. You see, it's a good thing, a nice revision material there. Right, that for me, I'm just gonna pick one from those that are easy and then we can take a look at it. So here we are. This one, I think I like it. Question 8. Here we are. Question 8, section B. So if you check section B there, I think it's page 11. Page 11. Do you see it? Right. Would you like us to go through this together or you wanna give it a try? Okay, no problem. Let's try this one and then there's a lot of them, gents. So enough food for everyone. Right. It says that in this diagram we have O, which is a center. Now for me, as soon as I'm told that I got a center in the circle, I already have to remember 3 theorems coming from CCT, but focusing on center. So we know that I start to eliminate them because there are always a lot of them, right? To eliminate them, I start with the diameter. Do I have a diameter here? I check the diagram. I don't seem to have a diameter. Can you see a diameter? No. Perfect. So I remove diameter out of my head. Now I know that there are only 2 left. So these ones should be line from center, perpendicular to chord. Is there a line from center which is perpendicular to a chord here? No. So it means I'm left with only one theorem. Angle at the center is twice the one as circumference. Is it there? Perfect. So it tells us that angle O1 is 2 times angle G, isn't it? Perfect. Angle at center is 2 times the angle at circumference. Now, already this, I know it can give me some stuff, but I'm gonna just write it like that for now. I can even do it with a pencil and then, check the questions afterwards. Now, then I'm told that we got a tangent. From tangent, I remember also 3 theorems, right? I'm gonna eliminate them again by asking myself, do I have 2 tangents? We only have 1 tangent, KH. So I know that I'm now dealing with only 2 theorems, which is tan perpendicular to radius and tan chord. Now, I'm going to start with tan perpendicular to radius. Do I have a radius and a tangent? We have it. Which one is the radius? Perfect, OH. So that means here we got a 90 degree, right? So already I'm going to write it. OHK is gonna be 90 degrees because tan perpendicular to rad. Now tan chord is the one that is left, ne? So which angles will be equal if we apply tan chord? H1 angle G. Angle G. check it because remember it says if I have a tangent and a chord, I should look at the angle formed by the chord at the circumference. Exactly, J. So you look at the angle formed by the chord. You see, if you're focusing on GH as the chord, check the angle that is formed by GH at the circumference. Mm, exactly. Because the 2 points are coming from the chord itself. You see, then they form an angle at the circumference. That's the one you look at. Are we okay with that? Mm. Uh yes, right. So I'm gonna come to that in just a second. Hold on to that thought for just a second. So this is angle J. We're using tan chord, ne? Tan chord theorem. Um, is there any other chord that we have here that now where we can apply tan chord? Now look at JH. JH is this side, but now do I have it? Yeah, right. This is the most common misconception I know that most of us try to make. Look at JH. Someone might argue that, okay, JH is still a chord. Do you agree with me? And then we still have an angle between the tangent and the chord. Do you agree? Uh-huh. We still have an angle between the tangent and the chord, isn't it? Right. Then we would want to say, so therefore the angle formed by JH, which is this one, should be equal to that. But then now that is not going to be correct, because when you say the theorem, it says the angle between a tangent and a chord is equal to the angle subtended by the chord in the alternate segment, which means they must not be in the same side. You understand? They must not be on the same side. If you are looking at chord JH, you must be talking about a tangent that is here. Then you're looking at this angle. Then you say that it's equal to that one. Is this okay? They must be in the alternate segment, meaning that they can't be on the same side. I can't look at this one and then look at this one again. They are now on the same side, which is what is not allowed. If you extend a chord, you make a tangent here. Well, if you're gonna say extend KH, right? Because you're doing IEB, if you extend that one, usually you won't get the, like, they won't make it wrong, right? Yeah, but you must do that only and only if you find that it's necessary, it's totally necessary, you see. Meaning you have exhausted all other options. Right. So, and then we have talked about that. So CCT is already exhausted. But then that's when now we can go to things like, fun talks. Fun talks. Then you start to check there. Do I have some parallel lines? Yes, we have parallel lines, ne? So which angles can we identify to be equal or H1 is this one is equal to G, ne? Alright, so let me just use a blue color since I had already said H1 was equal to this one. So I can write it here. So I'll say angle H1 is equal to angle G. Reason being that they are alternating, ne? Which lines are parallel? GH, GJ is parallel to KH. Perfect. And understand one thing though. Since O1 is 2 times G, that means actually you will see that when you substitute O1 as 2x, you can actually you can solve for G and you'll find that G is x, right? So if G is going to be x, that means here I'm also going to have x, then I'm also going to have x. Do you agree with that? Now I want you to check 8.1.1. What does it want? I think we've answered the question, gentlemen. Yeah, I think we've already answered the question, ne? So now you simply write now with a pen that this is your 8.1.1. You write the question after. So when you start here, you could do this, right? To make sure that you get your G. So you tell them that here, my O1, I'm given that it's 2x. So I'm going to write it here. So it's 2 times angle G. And then when I divide by 2 both sides, therefore G is going to be x. So you tell them this is the first thing that is x. Now, H1, we said it was equal to J, right? But we need to start with the one with G here. So now it's just because you wrote these things with a pencil, now you will see which one should start there, because now they must follow logic. We must not just say, you know, this, that. So since we know G that it's x, we said H1 is equal to G, and both of them are going to be x. H1 will be equal to G, both will be x because they are alternating angles. And then now that we know H1 that it's x, that's when you can come to this one with H1 here, and then you write it to say, okay, H1 is gonna be equal to J, and you just say both of them is equals to x. That's what you just say, and then give the reason, and then you are done with 8.1.1. So this means that now we can now go to 8.1.2. Now it says prove that H2 is equal to H3. Now we need to prove that H1 is equal to H3, isn't it? H1. Wait, we do know that angle H1 is x, ne? Oh, H2. Sorry. Why am I saying H1? They say H2, ne? This one. This is the one. We want to prove that it's equal to H3. And another way that they can phrase this question is that they can say, prove that OH bisects GHJ. That's another way they can say it. Prove that OH bisects GHJ, meaning that OH cuts this angle into 2 such that this one and that would be equal. So that's what we need to prove. Now, this theorem that we didn't talk about but we identified in 8.1.1, it might come in handy. Why am I saying that? OHK is 90. OHK is made up of what? Exactly. H1 and H2 only, ne? Yes, H1 and H2, perfect. So H1 from the previous question, we know that it's x. So we have x plus H2 is equals to 90 degrees. So now I just have to make H2 the subject. Do you agree that H2 is 90 minus x? Alright. Remember, fun talks for triangles. When I look at H3, it's part of triangle OHJ. And another thing this is a very big mistake we should never do again. After we have identified that we have a center, do not forget Dr. Cape Town. Don't forget that you have a radius, meaning that you must have OJ being equal to OH, isn't it? How can that help us though? Oh yes, okay. Okay, let's hear from Mr. Randy. You saying? Okay, so can I write first then that OJ is equal to OH, radii? Is this okay with us? Right, so if that is radii, then that means H3 should be equal to J1. Therefore, because these are angles, opposite, equal sides. One of the 4 properties of the triangles. Now, where to now? GH is equals to JH. Oh, you're saying angle G is equals to J. Oh, yeah, this one. Let me just write it. That this one is equal to this one. Yeah, that is true. And what will be our reason? We concluded that sides are equal. So our reason must start with sides. Meaning, sides opposite equal angles. Sides opposite equal angles. You see here, you concluded that the angles are equal. That's why your reason starts with angles opposite equal sides. But if you conclude that the sides are equal due to the angles, you say sides opposite equal angles. Ne? Just remember it that way. If I conclude that sides are equal, my reason must start with sides. If I conclude that angles are equal, my reason must start with angles. Now, actually, what would we get if we add angle O1 plus angle J1 plus angle H3? One eight. What is our reason? Sum of angles in a triangle. Now, O1 we know that is 2x, right? But now, J1 and H3, let's remember that they are equal. So actually, I can write this as 2H3. And why am I going to choose H3? Because I need to get H3 to be a subject. I need the formula for H3. Are we clear? I'm interested in H3. So I say 180 there. Now, if I take 2x to the right, this thing. So let me just do this. Let me try to move it up a bit. So if I take 2x to the right, I will have 180 minus 2x, right? Then if I divide everything by 2, then I can conclude to say H3 is equal to 90 minus x, isn't it? Which is the same as H2. So we conclude to say therefore H1 is going to be equal to H3. Because both of them is 90 minus x. Right. This 90 minus x. Are we understanding there that if I have to prove angles are equal, right, it's just a matter of making the one angle the subject and the other angle to be the subject of a formula, of a certain formula. Then when you find that they give you the same thing, you have proved that those angles are equal. You see? Yes. So please, whenever I need you to prove that any angles are equal, just try to get this angle to be the subject of a certain formula and the other one to be the subject of a certain formula using different theorems, using different properties or even similar properties. Then you'll be able to prove that. Right. Okay, I hope that was clear. and right. Perhaps we could also look at this one, which is quite similar. So you can now, this one you can give it a try. um hmm but I wanted one that would integrate also grade 12 topics. Let me, okay, it's fine, let's do this one first and then we'll go there. It's around page 16 there on that diagram. Oh my god, my screen. Okay, let's go here, control O, and then left, left, left. Can you see it? Right, now give this one a try, and then we can take a look at it. Maybe just 5 minutes or 10 minutes, right? It's fine. Okay, gentlemen, how far away? Is it that for 8.1 or? Okay, okay. Uh, so I'd like to assume 8.2.1. Did we attempt? Mm, mm. How do you know it's a trapezium? It looks like one. We can assume, man. Aish, aish, aish. We have to prove beyond reasonable doubt that it is a trapezium first. Mm, 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 mm. Oh yeah, true. Apparently. About Q1, whether it's equal to Q4. Hmm. I see. I see. No, I see. I see. I see. Okay, let's start with 8.1, gentlemen. How did we get? We are given that Q4 is x. Can you give me other angles equal to x? Mm. And oh, so Q4 is equal to T2, ne? Both of them will be x. Please write it this way. And you say tan chord theorem. Okay. T2 will be equal to W2. Okay. Uh, Angles in the same segment. You see that say? Yes. Remember I told you that this theorem it hides itself, so you need to make sure. As long as you have a cyclic quad, because you have 4 points here on a circumference, so it's three theorems related to a cyclic quad. So that tells you that angles in the same segment, we can't forget it. Okay, and then so the thing is that Q1 we can't say it's X. Uh, Oh, okay, I see. Yeah. Mm-hmm. So other ones equal to X. We're not quite sure which one can assist us. Because there, imagine, they told us there are five men. Imagine. Mm. to say S2 will be equal to T2. That is only we are not told. We are not told. That is the problem. But if we were told, then it would be true. Between which one and which one? Which triangles? QWR and PQW. Do we have pairs of angles that are gonna be equal in both? Mm-hmm. Mm-hmm. Q4 and Q1. Well, remember torques, right? For torques, they must form an X for them to be vertical, opposite. Do you see those ones? They don't form a perfect X. It's a bent X. Yes. Now, gentlemen, let me tell you something. This question, we are not gonna be able to answer it if we don't read the instruction properly. If you are stuck, you must always go back to the instruction, the full instruction. Is there anything you can spot from the instruction that can assist us? PWR. You said Q2 and Q3, or Q1 and Q4. Well, that would be true if they told us that, number one, if we knew that there was a center here. If we knew that there was a center here, then yes, this would be, so this would be 90, this would be 90. But we don't know whether there is a center there. And another thing, now, when they say bisect, the way you're looking at it as if WQ is bisecting this PR, meaning PQ is equal to QR. But that one won't quite help us because that's not what they're actually saying. When they say we are bisecting PQR, this is an angle. Do you agree? Right. Look at PWR. That is the angle there. Here it is the angle. Here is the angle. So if WQ is bisecting the angle, it's cutting it into two, isn't it? Exact. Exact. ST1 or W is equals to S2, ne? Still angles in the same segment. Right. There now I agree with you. Right. That instruction they like to put it and you must always check it out. Okay, but what others do we have? Q1 is equals to S2. Q1 is equals to S2. Q1 S2. Oh, yes, true. Tan chord theorem. tan chord. In fact, we have answered the question, but there are more, guys. Ne? There are actually more. If this is x, no, they are complete. Yeah, no, they're complete. They're complete. So those are the ones that are equal to x. So now, is it now easier to prove 8.2.1? What can we say? Mm-hmm. No, wait. This was proved. This one was proved, but because you only use alternate angles and the likes if you know the lines are parallel. You see, but we are trying to prove that these lines are parallel. So our conclusion now can be that indeed TS is parallel to PR. Then our reason now says, like you were trying to say, that alternating angles, you tell them that they are equal. They are only equal if the lines are parallel. So it should conclude that these two lines are parallel. Are we okay with this? Yeah, so when you use that, right, you, even for cointerior and corresponding, that's how it works. If you can prove that corresponding angles are equal, you say the lines are parallel. If you can prove that the cointerior are adding to 180, then you conclude that the lines are parallel. Right, now it seems like this link is going to just expire in a minute. But I would have liked if we can just look at a grade 12 question. I don't know if it's fine. I can send a link and then we just look at that. Okay, so I'm gonna just open a new link this side and then send to you guys. You can use that to join, so that at least the grade 12 one we also look at. It's been a long time since I did proportionality theorem, even similarity. Quite nice theorems, those ones. Okay, I got the link here and then I sent to you just now, so you can join that one. Okay, so we have proved that these lines are parallel, and then we could proceed with 8.2.2 just to further prove that now the angles there are equal. Now the issue about proving equal angles, like I said, you just have to make sure that you make Q3 the subject, you get what is it. You make P the subject, you get what is it. Then you can if they're equal to the same thing, it means that those angles are equal. How can we get Q3 there? Check Q3. 90. But now we don't know whether it's a radius there. Mm. Right, that's if you have proof that indeed this thing is a kite. And now remember, to prove that it's a kite, you need to prove that either the diagonals bisect each other, or you need to prove that the adjacent sides are equal, you need to prove that TQ is equal to QS and TW is equal to SW. That's how you prove a kite. Or you can prove that this is equal to that and this, yeah, this is equal to that. If you can prove this also, then it will be a kite. Then you can use properties of a kite. That is if this is a diameter. Yes, unfortunately we are not told. Yes. Oh yeah, now you're onto something, man. Do you see this one? Yes, yes, yes. That one we can definitely say that TQ is equal to QS. Indeed, these are sides, opposite, equal angles. That's true. And what else, guys? What else? Remember that I told you that we need to prove that TQ is equal to QS, and not only that, you also need to prove that TW is equal to SW to make this a kite. We want to make Mr. Ten's dream come true and make this thing a kite, man. We want it to be a kite, man. Please assist. Let's go. Okay. Yes. Mm-hmm. Line parallel. Yes, that's true. Line parallel to one side of a triangle. That is true. If you look at that big triangle, indeed these TW over that and SW over that, they are in the same proportion. I agree with you there. But them being the same proportion, does it mean they are equal? Mm. Mm. Well, we're told that it only bisects PWR, meaning this one. Mm. That is it there. That was the key, Menir. Yeah, that is the one. Do you see that those triangles, they can be congruent? Look at them. This one here, right? And this one here. Check it out. Exactly. South African. No, that one is a, but the angle is not. It's not included, ne? TQ is equal to QS. This one we proved it, ne? Angle T2 is equal to angle S2, right? Also we proved. Then we say we don't even have this one now, this letter. If we put K there, we would say QK is common. But that angle is not in the middle, man. Do you see it? Yeah, you'd want to use side-side angle. Yeah, this one. You have to have a side, and the included angle in the middle. TW is SW. Oh, here on this one. No, what we mean is that if this angle here, ne, it was in the middle here. In the middle of the sides that you are saying they are equal. You see, the angle will be in the middle of the two sides you are saying that they are equal. You feel me? That's when you can use side angle side. Yes. The area, yes. Oh, no, it can't. It can't as long as we are not told that the lines themselves are perpendicular. Okay, tell me something. What if we were to prove that T3 and S3 are equal? Do you agree that it will mean that this and that are equal? Okay. And what the theorem is saying here, right? What it wants is saying Q3, which is this one, we need to prove that it's equal to P. Do you agree with that? Okay. We need to prove that Q3 and P are equal. So, if we can get the P, right, and then Q3 will be fine. Now I want you to see something. Let's check angle P. If you say angle P plus angle Q1 plus angle T1, what do you get? 180. So that is in triangle PTQ, ne? So these are sum of angles in a triangle. Are we okay here? Now, we do not know angle P, but we know that Q1 is X, and then we do not know T1. ne? But I want you to check T1. I want you to check T1 here. Then I want you to check I want you to check this angle here. Are those angles equal? Exactly, ne? Angle T1 is equal to QSW, ne? Then we say exterior angle of a cyclic quad. Okay, perfect. So we know that T1 and WSQ are equal. So therefore, can I say that angle P is actually 180 minus X minus QSW? Alright. Now I want you to check Q3, ne? If I say Q3 plus angle W2 then plus QSW, what is the answer that we get? 180. Oh, still sum of angles in a triangle. Okay. W2, we know that it is what? It's X, ne? W2, it's X, right? Then we have QS, W is equals to 180. Now if I make Q3 the subject, what do I have? 180 minus X minus QS W, which is the same as this one. Then you have proof that angle P is equals to angle Q3. Man, you know what? Remember I told you that there's this part I liked about that acronym, Fun Talks. It said to us here, Fun Talks, and then it said 4 triangles are simply confusing. Now, the key is actually on the triangles. Whenever you are stuck on similarity, whenever you are stuck on congruency, whenever you are stuck on Fun Talks, whenever you are if you are stuck on also CCT, guys, this sum of angles in a triangle is always gonna be, it's gonna prove helpful as also exterior angle. You understand? Yes. And I don't know, I want to even check if we couldn't use exterior angle here. Let's see. If we check, S1 is gonna be Q3 plus X, ne? And then T1 T1 is Q2. That one wouldn't assist. Jo. Yeah, that one wouldn't assist. Okay, but it means from the properties, the 4 properties of triangles, what eventually assisted us was the sum of angles in a triangle, incorporating angles, exterior angle of a cyclic quad. So that is what we just need to make sure that when we are studying there, we look at that, right? So even the questions, right, make sure that you go back to the questions and you can be able to do that. So now there will also be similarity there, and you know, these other juicy questions. Now I'm gonna take one that we can take a look at. For grade 12 now. Here it is. Hey, quite a beautiful diagram. It's also taken from that document, guys. If we check, I think if you check around page 80 there, you should get it, ne? Hey, by the way, guys, all of those, ne? I'm just gonna, let me share the screen here. I want you to be, so that when you're practicing, you don't get stuck and say, but I couldn't find the solution there, so I just gave up on it. Maybe I want you to understand that when you're using this diagram, ne? This booklet, it has these codings there that are there. You see this? Yes, these codings will tell you the actual question paper. If it says KZN J18, it means KZN June 2018. If you search that paper, you'll actually find it. Ne? If you search NM17, National March 7, 2017, if you search that paper there, the memo, yes, you can find the memo. Ne? Now, speaking of which, I think I was on page 80 on this one. Do you see that it's written NJ18? But if I look at the start here, I see NM18, I see NJ18. So perhaps this might be national paper. This is June 2018, but N now, this coding I don't understand. Yeah. Or could it be June 2018, ne? Because I couldn't find it here. That's what. Oh, you see here it's National March 2017. Yeah, perhaps it's National June 2018. You see? And then maybe you can find it. Just this is for the sake of when you are using the booklet. Remember, it's also going to be useful when you're going to write your June exam. So yeah, so it's very, very much good to have it now and know how to use it. So let's look at this one. Quite an interesting one, man. Ooh, it's quite a lot going on here, ne? Exactly. C1 is 90. Angle in a half circle. OE is equal to OF. Very good to remember that. Radii, yes. Still on the center there. Which other theorem did we not talk about? Yes. Now, we have its converse. Its converse says if you have a line from center to midpoint of a chord, what happens? To midpoint, it's already going to the midpoint. Converse of theorem 1. Yes. So D1 there we say is 90 degrees because this is a line from center to midpoint of a chord. Okay, to midpoint of a chord. And It's converse of line from center perpendicular. There's line from center perpendicular to chord. That one you would conclude that the sides are equal. They are bisected. But if they are already bisected, we conclude that the line that is bisecting them should have been perpendicular to that chord. Yeah, quite an important one to remember there. Since guys, check something. If C1 and D1 is 90 degrees, what can you tell me about line FC and OD? That's true there. No. Coincidentally, they are not equal. They add up to 180. Yes, we say they add up to 180. No, but actually, we can use corresponding that they are equal. Do you see that? Corresponding angles are equal, meaning that angle C1 is equal to D1. Right? But this statement we're supposed to write it before we concluded parallel lines, though, so that the examiner knows that angle C1 is equal to D1. Since both of them are equal to 90, then you say they're parallel. Guys, I think we've answered 10.1.1. Yeah, 5 marks, imagine. Now, they want you to prove that DOE. Right, another thing is that once you have proved that the lines are parallel, already indicate that, fill in the rest of the dots. So you should know that now this, it means it's equal to that, ne? And then this one, and this one would be good. Yes, corresponding. Then these ones are alternating there, you can now play around with this. But another thing is that in this case whereby you have so many angles that are equal, I like to use letters. So I'm gonna use X here, then I'm gonna use X there, that they are equal because they are corresponding. Then I'm gonna use Y here and then Y there. Do you see that they are also equal? Corresponding, ne? And then this is also Y here. Right, yes. Yeah. Mm-hmm. Mm-hmm. The triangles. Yeah, that's true. Angle E is common. And knowing that angle E is common, you can prove that this triangle ODE is similar to the bigger triangle, isn't it? Mm-hmm. But what are we trying to prove here on? Wait, here they want you to prove that DOE, which is this one I called X, they want you to prove that it's equal to BAE. This one. Oh. To DOE. Yeah, it must be X. Sorry, can we agree that here it's 90? Angle C2 is gonna be 90 degrees. Angles on a straight line with C1, eh? Okay. Hmm. Yes. Which one? It's a cyclic quad. Which one? Oh, AFBC is a cyclic quad. Ah, man, you are done with this. It's AFBC, right? Ah, then you are done with this. Yeah, you see, you listened, man. You always go back to the instruction. Can that not mean that angle F is equal to angle A, which is BAE? Reason being that they are angles on the same segment. Now, along with that, knowing that now these it's x and x, do you still remember we had said that F was equal to DOE? What was our reason back then? Corresponding. Remember this one was parallel to that, right? Corresponding angles. Because OD, we said it was parallel to FC. So since these two are equal to F, then therefore it concludes that BAE is equal to DOE, because both of them are equal to F. Yeah, wow, that's very nice, James. That's very nice. Oh, by the way, then it means here it's 90 degrees, ne? Because C2 is going to be equal to this small angle. Angles in the same segment. Right. Yeah, by right, they must be inside of a circle. But then if it is something that they're telling you, then you can what? Then you can apply the properties, you see. Yeah, same thing as let's just say you prove to me that let's say you have proved to me that TCDO is a cyclic quad. You can now use the theorems of a cyclic quad, even though TOD is not having a visible circle. Do you see that? Yes. So please remember that. Then, man, the last one. The last one there. 7 marks. Yeah. By the way, once you find a question like this, what is the first thing that you do? You look for the triangles, but then you must have fractions there, ne? So, for us to have correct fractions, we need to look for the triangles. Let's look at AB, AB, and then we have AE. Do you see that? AB and AE, do they not form one triangle? Okay, so I will make this our first triangle. Okay, let me also have this one here. Right, so that means AB and AE, they belong to the same triangle. So I'm going to divide both sides by AE, so that I have AB over AE being equal to OD, right, over OF, right, because of that one day, right? So it's like I divided both sides by OF. Yes. Sorry. No, no. Look, we what we did there, we have not, like we didn't have, we're not saying we have two triangles and then already we are concluding that maybe the sides are in proportion, right, Mr. Tan? What we are saying there is that we just rearranged the fraction, and therefore we then say this is what we are required to prove, RTP. This is what we are required to prove. This is not something we've proved already. It's something that we are required to prove. You understand me? Yes. So we have OD and OF. If we check, here's OD and then there's OF. Do they make a triangle? They don't, ne? But then the reason why they chose OF is because OF was equal to OE. Do you remember? So we can substitute OF with OE like this. Then we'll have a triangle. Do you see that? So, therefore, we're working in the yellow triangle and the blue triangle. Then it makes our life very easy. Do you remember that D1 is 90? Right? D1 is 90 degrees. This was proved a long time ago. And then we just have to find also a 90 degree in this other triangle of ours. Do you see that you can have a 90 degree in the yellow triangle? But the question would be where? We can have a 90 degree here. Isn't it? And what is going to be your reason? You can say, so you start with C2 and that other one. So you say C2, remember, is equal to ABF, to FBA. No, we had said angles in the same segment. Remember, we had not said it in these previous ones. Yes, and then now that we know that FBA is 90, we can therefore say ABO is 90 degrees. Angles on a straight line, eh? Angles on a straight line. And now that we know this is 90, guys, we just need one more pair to prove similarity there. One last pair. That's it, man. That's it. Do you see it? Angle E is common. Yes, it's in the blue one, it's also in the yellow one, isn't it? Yes. So therefore we then say just the third one. So it means and guys, there was not even need to find E, because remember we had proved that this was X and the one inside here was X. Do you remember? Yeah. We had proved it here on the first one. Where is it? Here on 10.1.2. Do you remember? DOE is this one and BAE is this one. You remember? Yeah, so we can just say DOE is equal to BAE. We know we can just simply say third angle, but we just want to flex and tell them that we proved it long time ago. So therefore the triangles are similar, which means you tell them that now the naming is quite important. So we're gonna say ABE, triangle ABE, triangle ABE is similar to triangle what? Since I said AB and then I looked at this one, and the angle in between is X, so I'm gonna check also these two, whereby the angle in between is X. So I'm also gonna say ODE. ODE. Then we say angle, angle, angle. So we can say angle, angle, angle. Then from there, guys, you can then use the frog. You can then use the frog to get the sides to be in the same proportion. Now check, AB over OD is gonna be equal to BE over DE, which will be equal to AE over OE. Remember, I remember you said there's no need for writing the reason, ne? But you can just write from similarity if you want, ne? Then from there, that's when you locate these ones now. AB is here, AE is here. Now we want to prove it, Mr. Randy. And then OD is here, and then OF. We don't have OF, but we know OF is OE, ne? Yeah, so we can just take that one and say, therefore, AB over OD is equal to AE over OE. And then, remember, we need OD to be at the top, AE at the bottom. So we just swap them and say AB over AE is equal to OD over OE, ne? But then remember, OE is equal to OF due to them being radii, ne? So therefore AB over AE is equal to OD over OF. Then you are done. So that's why this was 7 marks. And then please guys, ne, just make sure that at each stage you just label your triangles, you label your diagram. Labeling your diagram will make your life very easy. If you try to do it by head, you're gonna get stuck. I'm already telling you now. Okay, you will get stuck. So yeah, oh as in like here on the naming. Or then she would write this part. I think what she's doing is just what I did, but in reverse. Because what I did, I checked the angles that were equal in both triangles before finding the name of the triangles. Then after finding the angles, I then used the angles to name the triangles. Mina, I used the angles, ne, to name the triangles, while your teacher is using the triangles to name the angles. I don't know if you get what I'm saying. Yeah, so if you choose to work to go to the triangles first, which is still okay, you can say, okay, I will say BAED or BAE. But the problem with that is that if I say BAE, then this side I say EDO, I might not be linking angles that are equal. You see, that's just my problem there. So for me, in terms of naming the triangles, here's what I do. Check this one. I look at the angle that I have. This is X, right? X is made up of BAC. That is X. Do you agree? Then I look at this other X here. it's made up of EOD. Do you see that? This on its own gives me my triangle. If I just say triangle EOD, I have to also say maybe BAE, this side, BAE. So I just follow the same order. Yes. You need to follow the same order. And now you can see that, check, this one has a 90 degree here. And then if we check here, the 90 degree is this side, isn't it? On D there. So check, how can I name them? I can say now BAE. I started from the 90 degree. Do you see that? This side I'm also gonna start from the 90 degree. I say maybe DOE. DOE. You see? And that DOE, believe me or not, is still the same as ODE when you match the angles. You see? Another trick you can use is to check the ones that are in the question itself. Since you have AB, then this is already a giveaway that my triangle should start with AB, then you know that it's gonna go to E last. Do you see that? Yes, and then if I'm using OF, which is OE, then I'll know that I can say OED. So you just have to match them, man, in terms of the angles that are equal there. Yeah, but trust me, the majority of the work is in you finding those angles to be equal. I hope this has refreshed your mind, gentlemen. Are we? Nay. Alright, no. In that case, man, please go and have fun talks there in your test, right? And then we'll talk more about these when we are revising. Alright. Mm. Yeah, it's Thursday. Is it? Okay. Then you can confirm with me there. Tell me so that I know we can prepare in advance. Ne? Yeah, if it's a Tuesday, we might maybe try to arrange for Monday. Yeah. Okay. All right. No problem then, gentlemen. All the best. I'll see you. Sharp, sharp.